I am Tim Becker. I am the engineering lead for the software platform at Becker Robotics. Over the past year and a half, my team and I have built out the DevOps at Gecko pretty much from scratch. Specifically, we've built out the internal cloud development platform, hence platform engineering. I'm going to talk through my experience, what went well, what didn't go well, our approach, and some specific decisions we made. I was lucky enough to have fairly ideal circumstances for building out the platform, so I thought I'd share those experiences as a sort of case study or conversation starter. What we built is definitely not a paragon of internal development platforms, not yet, but it's real and it's working. So a bit of my history, I've worked at a couple different kinds of DevOps teams. I learned a lot from each, and each had their share of successes and their share of anti-patterns. I kind of fell into DevOps, and the first team that I was on was more of an internal tooling team. We built our Jira instance and managed that, as well as our CI/CD pipeline, source code repositories. And we had a lot of pointless gatekeeping there too, where I'd jump on a call and click a button on a CI/CD pipeline that I'd never seen before due to some out-of-date compliance regulations. So I learned a lot there of like what it could not look like, but I also learned a lot of things that I took on to my next roles. Then I transitioned within that company to more of a platform engineering team, and that's a lot. We didn't call it that at the time. We didn't know that term, but that's a lot of where I learned a lot of what I do today. Unfortunately, we didn't have good access to the users, so what we built was really great, but it was a little overcomplicated. It was hard to onboard people onto the platform, and yeah, it just wasn't what they needed. But it did, again, have a lot of shared successes, and I especially learned a lot at that position. Then I went to a new company. I transitioned back into software development for a little bit, still had my hands in cloud stuff because that's what I was actually good at. Then transitioned within that company back to DevOps into more of a we're ops, but we do dev stuff kind of role. And again, share of successes, share of anti-patterns, good learning experience. Yeah. And then I started at Gecko. What does Gecko do? We build wall climbing robots that inspect infrastructure. We take that data, upload it to the cloud, process it, and then present that data to our customers to drive decision making around the life cycle of that infrastructure that we inspected. We work with power companies, oil and gas, pulp and paper, and we've started working with the U.S. military inspecting ships and missile silos. So if you're interested, you can go to our website, geckorobotics.com. We have some fun little videos and stuff there. But I'm not trying to sell you anything unless you have an industrial-sized boiler in your basement. I'm telling you this just to contextualize where I'm at, which is right there in the cloud. That's mostly what I've worked on so far at Gecko. So when I first joined, one thing that really surprised me is that DevOps culture was already pretty strong there. The teams built their stuff and owned it all the way from their IDE to production. We had strong documentation culture. There was lots of automation, and people were interested in doing the right thing. So one thing I had to be careful about was to avoid the anti-pattern of when you have a new DevOps resource, they become DevOps. And all of a sudden, people aren't owning their own solutions from all the way into production. If there's a cloud issue, you reach out to DevOps and ask if they can figure it out for you. So I had to be careful that I didn't ruin this, that was the culture that was already there. And part of this, trying to brand ourselves well, was a recent rebrand from the DevOps team to the software platform team. We couldn't be platform team because we also have a robotics platform. And this was really to be clear about what our purpose is and what we're working on, which is the platform. Even though there was really good DevOps engineering, DevOps culture there was a lot of things that were slowing down our software developers. And a lot of these had to do with because all of the engineers that were there so far were focused on their unique problems and what they were trying to do and didn't have this wider scope. So we were redoing a lot of work over and over again in each of our applications. And that's why, I mean, this was fine. It made sense. It was where a lot of startups are and a lot of companies are, where you throw stuff at a wall, see what sticks, and a lot of times you have a lot of cruft left over that you got to clean up later. And that's how you need to start. But eventually, as we tried to scale, That's why we needed a DevOps resource to help us scale and to have someone who cared about these little things that other people don't have the time, bandwidth, goals to be able to focus on. And fortunately, like I said, there was a pretty ideal solution for building it out. It was small, so we were able to focus on a few things, keep it simple, and really do a few things well rather than trying to do everything at once and be everything, do everything for everyone. We also had an engaged team, people who we were able to work closely with and get good feedback on and get contributions from. A lot of the early platform and the platform today is directly from contributions from the team and not our work directly. We were also greenfield with a clear-ish direction. We had a lot of existing things, but we decided that we would start to build from scratch and learn from the previous things that we had. And also, the work that we were doing was important. We just got our Series C. We were building a new business model with our software. So we had good runway, good support, and so we had the time to try to do things right instead of trying to rush solutions and fix gaps that we had in place. But even though, like I said, it was clear-ish direction, we pivoted a lot at first, which was actually pretty nice. We were able to get a lot of reps spinning up new applications, learning from our mistakes there, and not having those mistakes follow us for the rest of my time here at Gecko. We were able to shed a lot of that early tech debt and learn from our early wins and early mistakes. So now, this is probably a little generous, but this is where we're at. We have a lot of standardization, automation, and we're really heading in a good direction. So how do we get there? First of all, I'd like to talk about platform engineering in general. So what is platform engineering? This comes from basically how do you do DevOps? Like I mentioned earlier, I think there's a lot of wrong ways to do DevOps. I think the people who describe it the best is team topologies. They have DevOps antitypes that are really good at describing ways that DevOps isn't as effective as isn't doing what it's set out to do. And DevOps teams can get in the way or create their own silos. They also have ways that DevOps teams are effective, and those have really good descriptions. But personally, I like to oversimplify it into just two categories: site reliability engineering and platform engineering. And there is a lot of crossover between the two, but it really comes down to what is your goal? What are the things that really drive what you're doing day to day? Where site reliability engineering is mostly focused on system reliability, platform engineering, the main focus of our team is to empower the engineers that are around us. So we don't have our hands in the code, in the running code in production as much. We try to make it so people can do it themselves. And you can look at this list and see that there is still a lot of crossover. We still are concerned about performance, and SREs will still want to optimize software delivery. So there's a lot of crossover. It's mostly semantics. And what's most important is that you understand your goal and your role within the organization, and that is well documented, well communicated with everyone else in the organization. So for me, that means I need to be clear about my responsibility and my team's responsibility. For instance, if it's in the cloud, it's not necessarily our responsibility. It should be, if you built it, you want to run it. But that can be really hard. This expects a lot from software engineers, the you build it, you run it mentality. They already have all of their own problems that they're trying to solve and all their own skills that they're bringing to the table, and now all of a sudden they need to be cloud experts and be experts in everything that DevOps engineers are trying to do. So it's a lot to put on people. So platform engineering, the idea of like what we're trying to do is make this easier on our teams, so they can actually succeed in the building and running it themselves. This is done through golden paths. We try to make it easy to do things right and hard to do things wrong. We have guardrails and we have things set up so that it's easy to get to where you want to go. Someone told me a long time ago and stuck with me that it's really easy to do things in the cloud. It's also really easy to do things wrong in the cloud. So you have these big, great cloud providers, AWS, GCP, Azure, that they have a lot of choices and they try to make it easy on you, but that's how we get a lot of these famous data breaches where if you don't know what you're doing, it's really easy to make things insecure and do things wrong or overcomplicated. So we try to opinionate this and make these golden paths. Another big concept in platform engineering and DevOps in general is cognitive load. And I'm sure, and I know a lot of psychologists and other people on the internet can explain this better than me, so I'll go through it pretty quick. But it's the idea that your working memory only has limited capacity. If you're trying to hold too many things in your head, then your ability to do anything suffers, and you have trouble focusing on and improving on the things that really matter, and the interesting problems that you're working on. There's three aspects of cognitive load. There's the intrinsic load. These are your skills, the inherent complexity of the task. This means that you can't pull someone off the street and they can develop a Go backend for you. You have to have basic understandings of software engineering practices, languages, and yeah, these are the skills that you bring to a job. And this is something you can't make more simple. You can't reduce, but it's also not contributing to the actual problem that you're trying to solve, the interesting problems. Now, extraneous cognitive load, this is the irrelevant load. This is where do I need to go to see my logs, to troubleshoot my applications, to debug? How do I deploy this again? Which Python framework is this particular one using, and how do I install something with that? This is having too many tools and frameworks and overcomplicating things. This is what, as a platform team, we're trying to reduce to make room for the germane cognitive load. This is the relevant load, the interesting problems, the things, the differentiators that your company is solving for. And yeah, we need to make room for this by reducing extraneous cognitive load and not getting extraneous and intrinsic mixed up, where we think that this is just inherent complexity. No, this is something that we can make simpler, so we have room to do the interesting things. How do we do this? Opinionate. One tool isn't necessarily better than another, but it's definitely worse to use a lot of tools to solve the same problem. So we make a decision on how do we do compute, how do we, which tool are we using to install Python packages. And every time you run into a new use case that you might need another tool, you really need to be serious about a cost-benefit analysis of, is it worth adding the cognitive load to use this new tool for the new features that it's giving us? And sometimes the answer is yes. A lot of times the answer is yes. But you really need to be serious about taking cognitive load into that. Because if you do this well, you're able to automate everything a lot easier. If you only have a few set of services, your shared libraries and everything can only focus on a few, the few things that you have opinionated with. So that instead of having to target 5 different performance management systems, you can target just one, and that you don't have to keep everything up. You're able to do things better so that everything is interconnected automatically and everything just works together. So how do we do this at Gecko? It comes down to defining our purpose and keeping this in mind, and like I said earlier, really communicating this with everybody. So our core purpose is to empower engineers to create exceptional products. If we aren't doing this, then we're failing as a team. Everything we're doing should be leading towards this. But it is a little fluffy, so how do we do this? We try to make software effortless to build, deploy, and manage so that people can focus on their germane issues, their relevant issues. Our specific goals are reducing cognitive load, making the paved paths the golden paths, and also bolstering DevOps culture. So we have the top-notch collaboration, communication, and everything else that we've been talking about the past 2 days. So best way to start and continue is with the thinnest viable platform. You can't do everything all at once, and you also don't want to block everyone by saying, wait till we figure it out. So this could be as simple as a wiki page that says these are the cloud services that we use. And this is a concept I took from, and I've seen it other places too, but team topologies. And it's also called an iterative platform. So you start small, start thin, and add on as it's useful. And you want to keep it as thin as possible always so that you're never overcomplicating things, never being a gatekeeper in saying you need to do this way if you haven't actually put a lot of thought and a lot of work into that part of the platform. So as you're building it out, as it's thin, maybe too thin sometimes, what do you do for the things that you haven't solved yet? So this comes down to 2 cases. If it's not solved yet and people are blocked, and if it's not solved yet and people aren't blocked, they can go ahead and write their own solution for it. So if people are blocked, our strategy for this is to do it manually. We do it manually to unblock them. We write it down, and then we fix it forever later. And this is a little unintuitive, and it makes me cringe a little bit, always doing something manually and having this board with a lot of our manual tasks. But it has worked for us really well, at least at our scale. It makes it so the person is unblocked and they can keep doing their work, and it also makes it so we don't have to rush to find a solution. We can spend time to do it right, and bring that into the platform. And it also means that if they don't actually need it, which happens a lot, we didn't spend all this time and effort bringing it into the platform and making them wait for us to do that. They can go ahead and try it out, realize it doesn't work for them, and then we can revert it without having something added to the platform that isn't actually useful, that people aren't actually using. This is the way we keep it thin, and as long as we're disciplined about it, it works out well. The other thing is if they aren't blocked by something that isn't on the platform, these are things that they can just go ahead and do themselves, then we allow them to do that, where they're not blocked, and then we can take those things that they did and we can generalize them. We can take the wins from each team and share them. This is how we did our CI/CD pipelines. It wasn't something we prioritized at first. Everyone could write their own GitHub actions, so people did. And then when that was starting to become unmanageable, we looked at what everyone was doing, took the best of the bunch, and shared it with everybody so that we had the best solutions, because we shouldn't be doing everything. We're not the ones using the platform every day. We try to dog food it, but we're also working on the platform and not necessarily on front-end, back-end applications. So the people who know what they really need are the people who are using the platform itself. So that's how we get a lot of good features in the platform, is generalizing the things that people solve for themselves, and sharing them with the other teams. Another driving principle is simplicity, especially Yagni. This nothing has been more useful to me than this principle, and nothing has been more harmful to me than when I don't follow this. And I try to do endless pre-optimization and solving for problems that haven't actually happened yet. I run into this a lot, trying to predict the future, and it's better just to wait until you actually run into the problems so you can see all the nuances of it and solve it better than trying to guess beforehand. And a lot of times they don't actually end up becoming problems. So now you have more complexity in the system than you actually need, and your platform isn't as thin as it should be. This happens all the time. I overcomplicated our permission structure so that we need to redo that at some point. I added too many options for people to log in when everyone just uses one, and we added a lot of work for us when we're implementing it, and a lot of work for us as we're trying to maintain that. Another principle that we follow is self-documenting everything. I think that bad docs are worse than no docs at all, because you don't know which ones you can trust. It increases the cognitive load when people are reading something and then confused why it doesn't match reality, and then no one trusts the docs that are actually up to date. So how do you keep documentation up to date? There's a lot of ways to do this, and I'm constantly trying to learn better ways to do this. But one of the best things I think is have everything be self-documenting, from your code to your actual architecture. Documentation should only cover the gaps and be a crutch for things that are not obvious. So those are things that are not documented and things that are not automated. Automated processes that people don't actually need to know the internals on are automatically documented based on the code. So anyone's really interested in how that works, you can just go look at the code and see what it's doing instead of reading a document that might get out of date later on. An analogy for this is code comments. They can be overused. It's not just simply better to always use code comments, because if you update the code and don't update the comment, then the comment's lying, and that increases cognitive load and makes it harder to understand what the code's trying to do. Whereas if you just spent more time on the front end thinking of good variable names, maybe being more verbose for the sake of clarity, then this keeps itself up to date easier. And you don't get these lying comments. And the same is true for architecture. And how you do this with architecture is really good names. So really put a lot of thought into how you name your resources. Don't add the word bucket into your buckets. Don't add DB into your database. If I list the buckets in an account, I know they're buckets. I don't need to have the word bucket in there. If your project name is Radar, don't put the name Radar in every single every single thing if it has something else to do. I mean, sometimes you just like be really careful. Try to keep names as short as possible, as concise as possible. And no acronyms. I will die on this hill several times. Stop making acronyms. We have enough of them. They increase cognitive load. They can be really lazy and gatekeeping. It's hard when people join the team. You have to explain all these new acronyms to people. And then they become meaningless eventually. People forget what they stand for. So it would have been better just to take a nonsense word that had nothing to do with anything and attribute meaning to it than have an acronym where people are guessing at the meaning or getting it mixed up. No acronyms. The last principle that's really hard in practice but really important is optional adoption. Users are free to do things outside the platform. We don't enforce people to do everything the way we want them to do it. We just won't support that, and that becomes hard when people are using a new framework and they want to try it out. And we want to unblock them. We want to help them, but ultimately it protects our team to not support them because we're able to focus on the things that will provide the most value to the most people. So it helps our team and helps the most people. But also we don't want to be gatekeepers. We don't want to block people. So if they're able to do things outside the platform with this understanding that they're going to have to take on the responsibility of maintaining it and doing everything themselves, they're free to do that. And then if they have a win there and they solve a problem that we haven't solved for yet or find a new framework that's objectively better for our use case than another, then we can move people onto that and generalize those wins. Like I said, this is hard in practice. Sometimes we do need to have more strict rules around things or think we need to have those stricter rules. Still figuring this one out. So I'm going to get into some specifics now. Disclaimers. This is specific for our company, small company, and we're in specific technologies and stuff. One isn't better than another. These are what we chose. The more important thing, what I'll try to focus on more, is our reasoning behind these decisions. We're in Google Cloud. It wasn't my choice, but I don't mind it. I knew what I was getting into, and I took the job. I was excited about it. I come from an AWS background. I'm a Google fanboy, so it was fun to try it out. The short of it is there's some things I feel like Google Cloud has got better because they came later and were able to do some fundamentals, but there are a lot of days where I really miss AWS. So I wouldn't say one's better than another, but that's just where we're at in Google Cloud. Our big decision early on is how we're going to do compute. We are in serverless, specifically Cloud Run, which is basically a container in the cloud. We debated a long time, should we do Kubernetes? And I really think that would have been a mistake for us. Just keep it simple at first, and we could always pivot onto Kubernetes later if we needed to, and we haven't needed to. And that's saved us a lot of headache, a lot of time of doing the underlying configuration management stuff. I get emails all the time about you need to update your old Kubernetes clusters, and I don't actually need to do that because none of our active stuff is on Kubernetes. We put our front-end applications in it, even though they're static single-page applications. We could easily serve them out of a bucket or something, and there were some early technical issues we had with that aren't worth going into, but we also made this decision because the CI/CD is identical to the back-end applications, so those could match and we could share code across those two things. And this might change soon, we'll see. We also use Google Batch for serverless. This is an example of we ran into situations where Cloud Run wasn't good for longer running processes, so we trialed this out and it worked well for some cases. So first we have everyone start on Cloud Run, and if they need to, we'll help them move on to Batch. But again, it's serverless. It's basically just a container running in the cloud. The most important decision we made was everything is containerized so that we can move things from one thing to another easily. Another big early decision was we only have 2 environments. My experience at companies was, and especially at our size, no one really uses the 3rd environment if we have 3. Either everyone skips over the middle environment, or sorry, this clock is wrong up here. Okay, sweet. Sorry about that. Everyone skips over the middle environment, or everyone ignores the early environment, or worse, people are in one or the other, but not, and so there's a cognitive load, which application is deployed where. So we decided to only have 2 environments, and this has worked really well for us. The cases where we would need more environments can be covered by preview environments, which is on a roadmap, or ephemeral environments. Or we can set up if we need something for load testing or more sandbox or environment, or we're evaluating or we're trying to do a re-architecture, we can, instead of having a whole environment that we deploy everything to, we just set up a parallel service for just that one thing and are able to test that out instead of, so it's easier, it's simpler in a lot of ways than making this big, broad decision. I don't know about you guys, a lot of my job is figuring out permissions. So we have a lot of strategies for this. We try to do least privilege, which means starting with nothing. Practically, we start with nothing and add permissions until they get what they need, keep running into errors and keep fixing those errors. We do role-based access control, and the big thing here is try to, again, have really good names so that it's self-documenting, so that we have a role named Radar Developer, and we assign that to a person, and because they're a Radar developer, and they have everything they need to do to develop our Radar application. So the self-documentation there provides clarity. Someone starts developing on Radar, we assign that to them, they have everything they need. Now the challenge here is scopes. If you're too broad in defining your roles, then you violate least privilege. We run into this with someone needs access to BigQuery, so we need to assign them our data engineering role. They don't need everything that data engineers need, they just need the BigQuery thing. So too broad violates least privilege, but if it's too narrow, it ruins the point. If everyone has 4 to 6 roles, then it's not very clear what exactly they do. Someone comes and joins the team, everyone has a different set of roles. We don't know which roles this person is going to need. So this is a constant back and forth of trying to redefine our roles. How we unblock users is the same we unblock everything else. We manually grant the permission. If there isn't a precedent, we write it down, we research the best one, or more often than not, we just revert it because they only needed it for a short amount of time anyway. And so this also helps with not violating least privilege because they don't have roles that they only needed for one day, following them around for the next several months. And then, what happens if someone asks for something that you don't know how much they actually need? They don't know what they need. We always ask, if we don't have the business context of what exactly they need, we ask if they could use less, which is similar to the one napkin policy from New Girl. If they ask, for write permission, we ask if read is okay. If they ask for the permission in dev and prod, we ask if just dev is okay. And 90% of the time, it is okay. And if they need more, we can always elevate their permissions. Some specific processes that we've developed. We do trunk-based development. We only have one long running branch. We deployed a dev on merge and deployed a production on tag. This makes it so we always know what's deployed where. It encourages short branches because people can only deploy something if they merge it in. And if you need to roll back, you revert it and push it onto the branch, so you always know what's where. And this is a good example of something people have opted out of. We have teams that are on GitFlow because that's something their application is better suited for, and that's okay because their specific application is pretty different from the rest of ours, so we don't support it on the platform, but our platform wouldn't be very useful to them anyway, yet. Our Terraform strategy, I'm running out of time, so I'm going to go quick through this, mostly about being self-documented rather than being something we can tear down and spin up really easily. Good variable names, someone with no Terraform experience should be able to copy and paste it, and it's all human readable and easy to know what's going on there. Which means we abstract a lot of the complexity or accept complexity even in manual processes. Again, works because we're small and we have good documented cases for when it is manual in order to not make things more complicated. And the last thing is support channel. We have the infamous Slack channel for this, and we try to keep it reasonable. If someone DMs us, we try to push them to the transparent public Slack channel. If someone's trying to troubleshoot something, we ask them a lot of questions, lead them to solve it themselves rather than just us solving it and saying, okay, you're good. We explain our steps so that they are brought into the process. And yeah, we rotate who's watching this so that other people can be more into deep work. Clear about what is in our responsibility. How's it going? I think it's going pretty well. Mostly gotten good feedback from people when I ask, or ambivalent feedback, which is, I guess, is good too, because what we're doing is at least not blocking people. I'm meeting monthly with the team leads to hear what their biggest pain points are, figure out what isn't going well or what we could focus on next. We have a long way to go, and we do have a lot to clean up. Yeah, I think that we've learned a lot, and we're continuing to iterate. And I'd love to hear your thoughts. Connect with me on LinkedIn. Join the Platform Engineering Slack, platformengineering.org. I joined that recently. Wish I was a part of it a long time ago. But yeah, I'd love to hear your decisions, the interesting solutions and problems that you've found. Yeah, and any thoughts on my talk and things that I'm doing horribly wrong, please let me know. All right, thank you, everybody.